In my lab, we kind of address a couple of main questions. We're interested in the early evolution of vertebrates, our own group. And my lab's interested in basically how the first vertebrates evolved from their invertebrate ancestors. And then we're also interested in understanding how jawed vertebrates, so we're jawed, we have a jaw, but the very first vertebrates didn't have a jaw, and that was a big deal for vertebrates. Once vertebrates had a jaw, it's thought that they opened up many more possibilities for feeding, so that vertebrates could get larger and have more babies, and it was a big transition. So my lab's interested in this transition basically from an invertebrate to a vertebrate, and then we're interested in understanding how vertebrates got their jaw. And jaw is kind of a shorthand for a bunch of other specializations of the skull that evolved around the same time. So to understand this questions of where vertebrates came from and how vertebrates evolved a jaw, we look at two main model systems. Amphioxus. So Amphioxus is an invertebrate, but it's basically as close as you can get morphologically to a vertebrate. So it's a very, very vertebrate-like invertebrate. And it's thought to resemble what our invertebrate ancestors look like. And then to get at this question of how jaws evolved, we study another interesting animal called a sea lamprey. So lampreys are living vertebrates that are a member of this very old vertebrate group of jawless vertebrates. So lampreys, we shared our last common ancestor with lampreys very shortly after vertebrates were invented. So when vertebrates first evolved, there were just jawless vertebrates, and then jawed vertebrates evolved and split from the jawless vertebrates. So lampreys are a member of this jawless vertebrate group and are thought to give us a nice idea of what the best living approximation of what these jawless vertebrates look like. Right, so my lab kind of focuses on these two organisms, this Amphioxus, which is an invertebrate chordate, and then lampreys, which are jawless vertebrates. Now we look at the development of those two organisms and then compare it to more standard or more commonly used vertebrate model system. And it's really, the key is really the comparisons between these groups. So that's where the real power comes from. So by comparing these existing groups, you can find things that are in common. And when you find something that's in common between a lamprey and Amphioxus and a mouse or a zebrafish or a frog, you can be pretty confident that feature was present in their last common ancestor, and that gives you a little window. It kind of allows you to triangulate what these ancestral vertebrates look like, hundreds of millions of years ago.